this is going to be a two-part presentation. So I will preside over a short knockabout session first, and then James will introduce a much-needed note of sobriety and seriousness into the proceedings. So let's take it away without further ado. First of all, why do we have invariants? Before we get on to that, here's a question for you, part of the quiz. Who's this good-looking guy? Answers in the chat, please. Anybody who says it's me in a younger age will get marks deducted from their totals. Anyway, I'll leave you to think about that while I say the idea of the invariance is to give something to people who are developing in the MojaLoop system, something that they can look at quickly and easily to remind them what the orienting points of the MojaLoop system are. And these are technical orienting points, as you'll see when James comes to talk about them in general. But it's important to be able to have something which people can look at quickly and easily to remind themselves whereabouts in the MojaLoop landscape they are. And in another first, we have Ronald Reagan's sole contribution to Western culture. And of course, when you're in the middle of doing something, particularly development, you're trying to solve immediate problems and things like that, it's sometimes hard to remember what the overall picture of what you're trying to do is. And the point about the invariance is to try and get people to to retain a sense overall of what the whole product should be looking like. So now we come back round to this handsome geezer, who is, of course, Malcolm Arnold. I knew you all knew that. Malcolm Arnold, the famous poet, critic, and an all-round 19th century intellectual star. Now, one of the things that Malcolm Arnold did, and this was talking about poetry, but there isn't too much difference between developing code and writing poetry. He pioneered the concept of what he called touchstones. And he said, when you're reading a poem, you should have in mind examples of what you think the greatest, the most key, the most central poems and parts of poems are. And you should be comparing what you're reading with those things when you come to form your opinions. And that's really what the invariants are. They are touchstones that you can match your current development against and say, am I on the right track? Am I doing things in the way that the MojaLoop system overall would like me to do them? So, when we talk about standards, we don't mean commands that are impossible to reach. This is not a way of judging people. It's not intended to be a way of denigrating what people do or of holding people to impossibly high standards. What we're trying to do are foster collaborations which are what we would call inspirations to excellence. I mean, ways for people to understand how to really succeed by working together in developing the MojaLoop we all know will eventually come to pass. So let's look in a bit more detail. What are we trying to build? Well, it's basically a system that connects organizations, financial organizations, and sometimes, of course, when these are fintechs, they are not organizations whose sole purpose is financial, but they are organizations which need to be in touch with financial organizations. Now, these organizations that we connect are very different from each other. We want MojaLoop to be able to be used by huge international banks, all the way down to tiny village savings and loan associations. That's part of the purpose of MojaLoop, is that it shouldn't matter. Any kind of regulated institution, financial institution, should be able to join a MojaLoop scheme on the same terms as the largest bank. So a lot of what we do is designed to make sure that these institutions can operate with each other, because although they're very different from each other in constitution, in size, in capitalization, all of those things, essentially they're all doing the same thing. So it's rather like this. What we're trying to do is to mask the true nature of these institutions from each other, so that as far as they're concerned, they are just dealing with another MojaLoop institution. They don't need to know whether it's an institution that's like theirs or very different from theirs. The point is to allow these things to communicate in the way they would like to communicate, as we see, without necessarily worrying very much about what kind of institutions they are in the rest of their lives. So our objective then is to let them pay other people's customers as easily as they can pay their own. And that needs to be reliably, immediately, and irrevocably. So that's really where we're trying to get to. Now, the question is, are all organizations created equal? And we have another illustration here. Those of you with a detailed background in classical Western literature will doubtless recognize this as a scene from Virgil's Aeneid, in which our hero, Aeneas, visits the underworld and talks to his father, who, inconveniently for Aeneas generally, happens to be dead. But his father makes a prophecy about the future of Rome, and this, with slight alterations, is John Dryden's translation of that prophecy. And essentially, I want you to notice in particular the fourth line. So he says, Rome is there to tame the proud and to give power to those who are subjects, to those who are slaves, to those who are poor. And that's what MojaLoop is designed to do. Essentially, it's designed to stop huge financial institutions dominating the landscape of payments in the economies where we deploy, but to support and make things as easy as we possibly can for small institutions. That's one reason why MojaLoop tries to be simple. It might not always look that way, but that's one of the things we're trying to be. So we want to help the smallest and simplest account holding institution process payments exactly as well as an international bank does. And if we can manage that, we want the poorest customers to get exactly as good a service as the richest. That's one of the things that we're here for. So our focus is on the smallest regulated institutions, and we need to ensure that they are secure, reliable, efficient, and that they can do everything at the lowest possible cost. So how do we do this? Well, simplification is the first thing. And that's, by that I mean simplification of the MojaLoop product. We don't want the MojaLoop product to be any more complicated than it needs to be. What we want to do is to provide the building blocks that individual schemes, individual implementers, as you've heard from the Gambia this morning, for instance, to add to it, to change it, to make it work in the way that's most efficient for them and their particular situation. So one of the things we don't want to do with the MojaLoop product is to build into it specializations of various kinds, by which I mean things that are appropriate for some markets but not for others. Our basic position is that payments are the same the world over. And what we try to represent is the nature of payments and not payments as they are implemented in particular jurisdictions. That's for the individual implementations. We want to provide functionality to enable people to change the MojaLoop implementation, to build it in a way that suits their local environment. But we want to make MojaLoop itself something which represents payments in general. Automation, then, is the next thing. It's a general principle that says every time a real person looks at a payment, it costs a poor person money. It raises the overall cost of processing payments in the system. And one of the things that we want to do, we want to focus on very strongly, is to make sure that people don't, I mean people by which I mean real people, don't have to spend time verifying that things are working correctly, that everything is going fine. We automate that in ways that mean, we hope, that people can trust that if a payment goes through the MojaLoop system, it's gone through it in the right way, it doesn't need to be checked, it won't need to be remedied. Finally, we look at cost reduction by design. Now, we see a lot of, we have a lot of people come to talk to us about their fabulous and very often extremely complex solutions to the problem of payments. We, broadly speaking, do not want to be implementing things that are extremely complex. Because, first of all, MojaLoop needs to be something which a large, broad community of people can contribute to, can understand, can add to. The more complex the things that we do, the more difficult it's going to be for people to take them and make of them what they need to in order to get what they want. For instance, one of the threads I think that ran through James's presentation this morning about audit logging was the idea that we didn't want to make this more complex to implement than we had to, where a simple solution gave us as good results as a more complex solution. We would always choose the more simple solution. So basically, that's smart thinking versus high concept. And the reason we all bow down to gurus like Professor Bush is that he's able to do the smart thinking without lighting on the high concept stuff that dazzles everybody else. Okay, so let's look briefly at simplification. So our principle basically says all payments are the same. They're all push payments. That is, we don't support pull payments. We don't do direct debits, nothing like that. We always have push payments. It's an important point which we've knocked up against on a number of occasions, I think I could say, in our desire to design new parts of the system. The switch never changes the content of messages. It's a very important and fundamental principle at MojaLoop that the sender of a message signs that with a non-repudiation signature, and that the receiver of the message can always satisfy themselves that the message really was sent by the person who is supposed to have sent it, and that it hasn't been altered in transit. That's a fundamental principle of the way in which we do things, and it's one that makes our lives more difficult in some cases than it would otherwise be. But it's such a valuable principle that we want to hold on to it at all costs. Also, we've recently developed a published accounting model, which enables us to clarify to accountants and indeed to bankers in general how MojaLoop manages payments. That's been a problem in the past because when we've spoken to people like that, they've said, well, I don't really understand how this works at all. So we spent some time and effort over the past 18 months to 2 years to develop a published accounting model and to modify the way in which MojaLoop processes payments so that they are in harmony with that published accounting model. And one of the first fruits of that will be that the Tiger Beetle implementation, which you'll hear a bit more about in the near future this afternoon, does implement the published accounting model. Automation. Well, we have a process that we call agreement of terms. So before a payment is executed, the parties confirm, each of them, that that payment can be made, that the parties are legitimate, that the fees are acceptable to the customer, that everything that needs to be there for the payment to succeed is there. And that squeezes failure out of the payments process. And the fact that we enforce execution according to those terms provides further confidence to everyone. Also, we time payments out. So that means that there's always, everybody who uses a motor loop system can rely on the fact that a payment will complete, will be finalized one way or the other within a given time frame. So it's not like, for instance, large-scale payments via SWIFT or something like that, where you send a payment and a couple of days later you might think to yourself, I wonder whatever happened to that payment. But you have no obvious way of finding out. The Moja Loop principle is that there should be a deterministic outcome for a payment, and that everybody should know, or everybody involved with the payment should know what that outcome is going to be, when that outcome is going to be finalized. So that means we don't have the delays from fire and forget systems like SWIFT, and we don't have systems, we hope, which are clogged with unnecessary queries, because people can be confident, senders can be confident that they will get a response within a defined time. They don't have to keep asking, have you finished yet? Have you finished yet? Have you finished yet? Those of you who've been involved with UPI will know that one of the biggest problems that UPI has is that quite small problems in the system rapidly become large because everybody, all the banks who are engaged in the system, are constantly asking, what happened to my payment? What happened to my payment? We try to avoid that for obvious reasons, not just because it makes our life easier. Also, we use exclusively fixed point arithmetic. So that means that we don't have reconciliation problems, at least in principle. The values, the arithmetic values of payments and things like that are always calculated using fixed point arithmetic. We never use floating point. Then cost reduction in operation. Well, we increase participant confidence by guaranteeing settlement of funds. We insist that participants pre-fund their transfers, so the recipient can always guarantee that there is sufficient money available to settle those obligations. We reduce liquidity requirements by trying to settle as often as possible. Now, that's not always easy because in some cases the settlement mechanisms are not always available. But when they are available, we try and settle as often as we can, and we're also trying to work with implementers to provide ways in which they can get to our ideal, which is that every payment is settled at the point when it is actually made. We have some techniques which are being used successfully to do that, and we're certainly willing and interested to talk about them with other potential implementers to see if it might be possible for them too. Don't rely on expensive security techniques. We use the public internet, we use standard encryption techniques which are generally understood right across the developer community. We don't do anything smart, but we do things that are secure. And we also, as I've already said, support participant confidence by the pervasive use of non-repudiation signatures. We also want to provide guaranteed, secure, and tamper-evident central storage for messages. And James was talking about that earlier on. That's part of the audit logging requirement. And we don't want to rely on long-running conversations because multiple short conversations obviously are much more reliable than long-lasting conversations, which are more likely to get interrupted by service interruptions and things. As I've said, we use the public internet, which means that we don't have to insist that small institutions have things like virtual private networks and other expensive things to keep connections going. But we need to compensate for that, and we do that by having multiple short conversations, and also by having idempotency checks, which make sure that when someone retries something, it is recognized as a retry and it isn't recognized as a new payment execution request, for instance. So, cost reduction in the code, and that's in deployment for people. As you know, it's free open source software, 100% soup to nuts. All the components we use are also free, are also open source, and that's very important for us. We use standard industry best practice in standard ways. We don't try and, as I say, do things that are terribly complicated just because they're new, they're interesting, they're shiny. Our view is that invention is something for implementers to do. It's about the application of the techniques that we produce, not about the techniques themselves. MojaLoop is made up of small, easily understood modules, and mostly that's true, I think. The modules have a single function, generally speaking. We try to enforce separation of concerns, those sorts of things, to make sure that if you see a function in MojaLoop, it should be clear immediately what it does, and perhaps more importantly, what it doesn't do. And inter-module communication is restricted to near neighbors, so we don't have, or we try to avoid where we can, situations where modules are calling out to lots of other modules in quite different parts of the system. And also they're guaranteed by secure access control. So that's a way of making sure that the modules are not misused. So, what about performance then in this context? Well, what sort of performance are we looking for? Maximum performance. This is a special James slide which has an extremely fast car on it. I know he likes those sorts of things. But no, we're not interested in that. We're more interested in the best energy performance ratio. Now, someone told me once that the bicycle was the most energy efficient form of transport ever invented. And that's what we're looking for. We want to help people get the best possible performance out of the hardware that they've got, so that they don't need to buy more than they really need in order to do their implementations. And we're constantly working to try to bring down the cost of functionality for MojaLoop. I mean, the infrastructure cost of functionality for MojaLoop. So that's something, again, we have a performance work stream, and I'm happy to give praise to them for the extremely good performance improvements that they've managed to get using the same hardware. So essentially, the sorts of things that they've been able to do have been not increasing hardware, but getting better performance out of the hardware that we've got. And that's the focus that we will continue to have in that area. So, what's the future of the invariants then? Are they? It's written on tablets of stone. Well, no, they're not. They are ways of reaching the objectives that I've been talking about. They're not the same thing as the objectives themselves. If there is a better way of meeting those objectives, then in principle we can change the invariants. But they're our way of meeting those objectives. And what I mean by that is that they carry in themselves the history of everybody who made MojaLoop what it is today, about the community. And those of us who've been with MojaLoop for quite a long time will recognize the huge contributions that were made by people who are no longer part of our community. But their commitment lives on in these invariants. So we can change them, but we don't want to unless there's a really good reason. But one of the things I want to say at the end of this is to ask anybody who's interested to come and join us on what I would call our journey to the future of payments. And I sign off, of course, with another poem by Yeats, whom I'm sure you will all recognize. I leave you to ponder on that, and I will hand over to my glamorous assistant, Professor Bush, who will do some more presentation on the specific invariants themselves.
Thank you, Michael. I hope I am unmuted and everybody can hear me. Well, I'm going to really struggle to follow that superb talk, Michael. And maybe this will, unfortunately, bring us all back down to ground slightly. So Michael's just done a fantastic job of explaining the raison d'etre for the invariants, what they are, why we have them, and he went some way to cover some of the details at a higher level. But there is a considerable amount of detail hidden under those top level headings that Michael mentioned, like security, reliability, efficiency, cost effectiveness, for example. So what I wanted to do is, rather than leave things at a high level like that, give you all a place to go next. The invariants, I hope you will appreciate, are quite important from a perspective of the MojaLoop project as a whole. So I would encourage and invite you all to have a read through them in some level of detail. You don't necessarily have to be technical or an engineer to understand them. They all relate to some of those big headline points that Michael mentioned. And I very much hope they'd be understandable, at least. So the way to find the documentation on the invariants is to visit our wonderful documentation website at docs.mojaloop.io. When you arrive at that site, you'll be presented with a landing page. So our documents are broken up into 4 main sections: adoption, community, product, and technical. The invariants actually live in our community section because they're standards, guidelines for the community of people who work on MojaLoop to be guided by. In the community section, you'll find a left-hand menu on the side of the page. One of the top level headings, standards. So you can read all about not just the invariants, but the other standards that are in place in the MojaLoop community as well. But the first item on the standards page is in fact about the invariants. They're super important base level principles. If you follow the link to the invariants, you'll find they're grouped into 3 main sections. The first of which is general principles. Now, I realize that we're already at time for this session, so I'll not linger too long on any of these individual ones. What I might just point out to you, though, is how these link to those themes that Michael was referring to, the principles of security, reliability, efficiency, low cost, simplification, automation, and cost reduction by design. So in this list, this numbered list, you'll find a heading with a statement. These statements are usually 1 or 2 short sentences that try to capture the fundamental objective of the principle in question, with some notes underneath it. So Michael spent some time talking about how we separate the concerns between the agreement of terms on a transfer and the actual transfer of liquidity from one participant to another. So the first one, the primary function of the platform is to clear credit push payments in real time and facilitate regular settlement by end of the value date. That's a MojaLoop invariant. You can read about the details. Usually there's some explanation about the rationale why this invariant exists. So most of them have some direct reference back to those principles that we're trying to maintain. So, for example, straight-through processing means that no manual interventions in the execution of payments or settlements should be required. Well, that links directly back to the idea that whenever a human has to look at a payment, it costs a poor person money. So by upholding this principle when we design and implement our software, we keep the cost to an absolute minimum, and we have as minimum impact on the lives of your average everyday person as possible. The general section is quite long. It talks about the way the API should work. Michael mentioned the difference between synchronous and asynchronous APIs and why we use those. So the rationale is included in this document. Details of why and how the transfer API is idempotent. That's the retry mechanism. In degraded network conditions. there's an entire section on the security and safety of APIs, which talks about the non-reputability, confidential nature, and tamper-evident messaging formats, and why. Authentication, our 3 levels of transfer security are detailed in here, and why. Then one final section on the operational characteristics, and this talks a lot about the reliability, efficiency of the platform operationally. So when designing our software, when choosing which patterns to follow, which building blocks to choose, and how to deploy those to make them deliver the services of the payment scheme, what should we be thinking about? What are the principles that we want to follow? So this talks a lot about having no single point of failure in the system, having multiple redundant instances of every service, be able to handle any request, and how the platform should degrade gracefully when conditions are not ideal. There's a lot of detail in here that I would encourage you to read, especially if you're thinking about contributing to MojaLoop from a technical perspective. It's important to have at least read these, so they might ring some bells in your head when you're writing your code or designing your feature. Towards the bottom of this section, you'll find some reference back to the level 1 principles. The level 1 project is not talked about a huge amount these days, but in the very early days, MojaLoop was designed as an embodiment of the level 1 principles. Level 1 was a project that came out of the Gates Foundation to try to figure out what the characteristics of a really inclusive national payments system would be. MojaLoop tries to embody those principles as best as possible. So in many ways, as Michael said, this set of invariants, although not set in stone, you might say if they can be changed, they shouldn't be called invariants. Well, perhaps, but we can debate that over some beers one night at the next in-person MojaLoop conference. So without wanting to run too far over our schedule, we're already 5 minutes over. I will leave it there. Please reach out to any of us if you can't remember how to find these documents. Docs.mojaloop.io. Follow the community link. There's contributors guide, all of the processes we follow, but most importantly, the MojaLoop invariants are listed clearly. Please read them, get stuck in. Feedback is always welcome. This is a living community document. So thank you very much, everybody. And thank you, Michael, for your kind words. You flatter far too much. Back to you, Plune or Tulo, whoever's running things.
It was my pleasure.